The top one was 20.3 meters and 17 degrees. Morning.
I got 30 degrees. Because what I
How
got
did you calculate that?
is what I got is the opposite side being 6,
Right.
and then the bottom being 10.4.
It should be 19.4 because you have to add the 10.4 plus the 5 and plus the other 4.
Okay, that's why. Okay, thank you.
Okay, good. And the other one was 19.5 meters and 345 degrees. Morning.
I got 357.
So what did you do? How did you calculate that one?
Because I got 87 degrees because the 19.45, I guess I did the inverse tangent of that. I got 87, unless did I calculate it?
Well, inverse tangent of what?
19.45,
Where did that come from?
the hypotenuse.
You should always have two, when you're finding like one of the trig ratios, you always need to have two things. And if you're using tangent, it should be the opposite over the adjacent.
Okay.
So for that one, it should be, if you're using the inverse tangent, it should be 4.9 over 18.9. Would be the opposite and the
Okay.
adjacent. Do you see it?
Yeah.
Yeah. Which the theta will turn out to be 14.5. And then you need to subtract that from 360 to find the CCW. Okay? Any other questions about those? No? Okay. Now we're just going to keep practicing these today. I think this worksheet does a nice job of kind of taking you through step by step. So for the first part, or for like just the very first line, I guess they're not really numbered, you just have to find the x and y components, and then they start having you add them. So they draw each of the vectors, and they want you to also draw the combined picture of the vectors after you found the two components of them. So let's do that second one together. Okay, so for each of these two vectors, we're going to find the individual components first. So we'll find the x component and the y component. So how would we find the x component? Cosine of 20 equals, well, we have to set it up as an equation first. So the cosine of 20 is, cosine is adjacent over hypotenuse. So that will be x over 12. Right? And then we have to multiply by 12 to get the x. So x will equal 12 times the cosine of 20.
which is
it?
11.27.
11.1.
27.
Sure. And then we need to find the y, so how would we find the y component?
Sine 20.
Sine of 20 equals y over 12, and again you have to multiply by 12 to get the y. So the y will be 12 sine of 20, which is,
4.1.
let's keep our rounding
Yeah.
consistent anyways. If we want to go to hundredths, what would that be in hundredths? 4.1.
I think it was 4.10.
Yeah.
Oh,
I pressed the clear button, but.
okay. And for those of you who are in advanced math, we've talked a lot about using the store function to keep it the most precise that we can. And we've talked a little bit about it in calculus as well. So you might want to store these however you see fit. Sometimes if it doesn't make sense, like A and B, what we've been doing with exponential functions, I like to write down what I'm going to store it as. So like be like, okay, well I'll store this as A, and I'll store this as B, and then I'll store those as C and D, or whatever the case may be, so that when I'm going to add them together, I can keep it as accurate as possible. But that's up to you, however you want to do that. Okay, it won't affect it as much with this as it would with the exponentials. Then you need to find the x and y components of this one. And we'll add them together.
Are they intentionally supposed to be like the same?
Yes. And they're going in the same direction. Both of these are going in the same direction. The x's are both going to the right and the y's are both going up. So we can just add them together. If one is positive and one is, or if one's going to the right and one's going to the left or up and down, we need to subtract them.
It's gonna be the same answer for all of them, right?
Yes.
So it's 15.38, and your picture is just a sketch. So it's not accurate drawing. And then you need to find what the magnitude and the direction of the resultant will be.
Why is it one?
Because it would be opposite over adjacent, and we said the opposite and the adjacent are the same, so if I divide them, then it will be 1. You could write 15.38 divided by.
Do we have to find the revolver?
Yeah.
Yes, ma'am. Okay. So that's what we'll do for those. So, let's see what time. 10, 12. Let's just do, you can have the rest of the time in class to work and do the rest of the picture ones. You don't have to do the word problem ones. Since you're not numbered. Olivia?
On the very bottom, when it gives us a 90-degree angle,
Yeah, I don't know.
what do we use for our y?
That is the y component.
So the y would
There won't be an x component for that one.
since it's just a straight line.
Yeah.
Okay.
So there's no x component, 0? Yeah, I got 0.
Yeah.
And the y component's, do we do cosine of 90? Or
30
just-
meters.
Okay, you just put 30.
Yeah.
If you do the cosine of it, you get 30.
Okay, thank you.
Yeah, if it's already a perpendicular line, you don't have to calculate the components. I mean, yeah, you don't have to calculate them, you still have to write what it would be.
And for this one, would you have to subtract the bottom ones, because this one's going north and that one's going south?
Yes. So figure out which direction it would ultimately be going, which one's longer, and then subtract them. Or if you want to think of the up one as positive and the down one as negative, and then if your answer's positive, it would be going up, and if your answer's negative, it would be going down. You can do it that way. You know what I'm saying?
Yeah.
Yeah. And if you need separate paper to work these out on, that's fine, there's not a lot of room.
So you want us to do the back, the first problem on the back?
Yes, please.
confused on what you said, like for the bottom problem. I understand that like the x is 0, but how would you find y? Would you just do sine of,
It's just, remember these are like the horizontal and vertical components. So the y is just gonna be the 30, because that's the only part that's, they give it to you already. Lauren.
oh, I was like, wait, what? Are we taking a picture?
Yep.